We have learned detail structure of an atom inside previous video, which is available in description $. In this lecture we will study about the particles which make atoms and differentiate them. Three key terms are associated with atom: atomic number, mass number and isotopes. Atomic numbers are number of protons in an atom and denoted by Z. Mass numbers are number of protons plus neutrons in the nucleus of an atom and denoted by A, whereas neutrons are obtained by subtracting atomic number from mass number. These neutrons are denoted by N. An atom of an element has same number of protons and electrons but can be changed. Protons and neutron are present inside nucleus of an atom, and most of the mass of an atom is combined mass of protons and neutrons. Protons and neutrons inside nucleus are held together by strong nuclear force, which is due to neutrons, and keeps proton inside the nucleus by balancing electrostatic repulsion between protons. Some elements has more than one type of atoms due to difference in number of neutrons inside nucleus. This phenomena is called isotopes of an atom, where atomic numbers are same but mass number of an atom are different. These isotopes are of great importance to define an atom, either it is stable or unstable. Let's try to understand concept of isotopes of an atom by taking example of hydrogen atom. Hydrogen atom has three isotopes: first is protium, second deuterium, and third is tritium. If we see into the structure of these isotopes, in protium there is no neutron and still it is highly stable. Why this happens is we know that neutron work as glue to keep protons in nucleus. The answer is neutrons balance the electrostatic force between protons by its strong nuclear force. Here no other protons, so no repulsion and no need of strong nuclear force as well, and proton is stable, which makes whole isotope stable. If we break down protium particles, we have 1 electron, 1 proton and 0 neutron, so its atomic number is 1 and mass number is also 1. Second isotope of hydrogen is deuterium. Its mass number is 2 and atomic number is 1, which means that it has 1 electron, 1 proton and 1 neutron. It is also stable because proton to neutron ratio is equal, both held together as no other force is present. But if see third isotope tritium, it has mass number 3 and atomic number 1, again electron and proton are 1 1 but number of neutrons are 2, which makes it unstable due to increase in proton to neutron ratio. Maybe you have a bit understanding of the question why isotopes exist. Why nature permits isotopes. So in simple words we can explain this phenomena as number of protons and electrons in atom of an element remains the same, but its mass number can be different due to difference in number of neutrons. This is the reason behind the existence of isotopes. But here the question is why it happens in nature. The answer is to gives atom stability by keeping protons within the nucleus, and for this purpose neutrons presence is necessary, which held together protons by strong nuclear force by reducing repulsion between protons up to a certain limit and make them stable, and number of neutrons affect the mass number, which gives us isotopes. As we see that neutrons act as glue to keep proton within the nucleus. But it happens up to certain limit where proton to neutron ratio has no significantly different. Then question is what happens if proton to neutron ratio exceeds certain limit by adding more and more neutrons or in elements with high mass numbers. The answer is atom becomes unstable and the neutrons inside nucleus due to high energy becomes exited, which leads to their decay to get stable, which we significantly noticed in higher elements, and the phenomena is called radioactivity. This happens because greater number of neutrons increases nucleus size, which makes them far apart from protons, and we know that strong nuclear force is short range, which becomes ineffective due to increase in nuclear size, and atom becomes unstable. Now we understand the reason behind instability of isotope with high proton to neutron ratio by visualizing in nuclear model in figure, where you can see that number if neutrons are greater in number, which increases size if nucleus, and distance between proton and neutrons is higher, which ineffective the nuclear force. If we compare stable and unstable isotopes, we see that in stable isotopes proton to neutron ratio is balanced. For example, isotope of carbon, which has atomic number 6 and mass number 12, which means 6 protons and 6 neutrons. This is perfectly balanced proton to neutron ratio, and that's why carbon-12 is highly stable. In unstable isotopes, which we called radioactive isotopes, proton to neutron ratio is not balanced. For example, carbon-15, whose mass number is 14, which means it has 6 protons and 8 neutrons, and ratio is not in balance, which makes this isotope unstable. This can be visualized in atomic model of these isotopes, where we can notice difference in nuclear size and number of neutrons visually. Here carbon-12 is stable and carbon-14 is unstable due to difference in neutrons number. So neutrons are the most important part of an atom in terms of its stability and related phenomena. What happens with unstable isotopes? The answer is unstable means high energy, which makes them excited and they try to be stable, and for this purpose they lose their energy by decaying into proton and electron. This phenomena of neutron decaying is called beta decay. In beta decay, a neutron is converted into proton and electron. Why this happens is due to keep stability of an atom. Number of protons and electrons should be same, and second thing, ratio of proton and neutron should be balanced. In beta decay both conditions are satisfied. As neutron decays, its number within nucleus decrease and proton and electron number increases due to conversion of neutron into proton and electron. This balance the whole atom. Now we take examples to understand this. First we study isotopes of hydrogen in which protium and deuterium are stable due to balanced proton to neutron ratio, whereas tritium is unstable due to increased number of neutrons. In second example we take isotopes of carbon in which carbon-12 is more stable due to equal number of protons and neutrons, which make them perfectly balanced, whereas carbon-14 is unstable due to 8 number of neutrons in respect to 6 proton. Reason behind all this is the increased distance between protons and neutrons within nucleus. The unstable carbon-14 is become stable by beta emission, in which neutron is converted into electron and proton. Now we study what is the importance of isotopes in nuclear physics. In nuclear reactors where uranium-235 is used for energy purposes, highly significant. In medical field, isotopes are used as nuclear medicines to treat cancer and other high-risk diseases. For example, iodine-131 is used to treat thyroid problem. In carbon dating and archaeology to find information about ancient fossils. Now with all these explanation and reasoning we recap in end to conclude a reasoning statement. In short, isotopes help us to understand why some atoms are stable and some are unstable. The key factor is neutron to proton ratio within nucleus of an atom, which keeps balance between proton repulsive force